unique topic. So this topic will divide into two sections, but I want to make sure the first sections you all understand. So let me, yeah, so I'll make you in mute all. Okay. Ready? I'm just keeping you guys in mute in case if you have a question, please unmute and ask questions. So today we are going to cover is called linear problem solving. They call linear problem solving. How many of you know about it? Linear problem solving. Anyone on phone? Do you know how linear problem solving works? Anyone?
Meaning it is linear programming or something else?
It's a linear programming. You're right. So how do you work with the linear programming?
It's difficult. I forgot.
Anyone else? Very interesting topic. I'm pretty positive you will like it. Mike, Matthew, any suggestions? Suresh? Yes or Abhi?
Yeah, the linear, I guess, I'm not sure, but the linear programming, when you get a relationship, a steady relationship, that you count on predicting future.
Yes, you're right. You're right. So if you have like a equation like this, m, x, right? So you can see here x and y has a linear relationship. But if I use this thing, y equal to mx squared, then that's not linear. So then what is linear? Linear means line. And in x squared, if you do this thing, you can go like that way also, or you can go this way also. So what does that mean? So think about like in a grade 2 or grade 3, you might have studied a graph, right? So if you see graph, this is the x graph, x-axis, which is the positive side, right? And if you think about this is the negative side, right? So, and this is the y, same thing, positive side of the y, and this is the negative side of the y. So when you do linear, when you say linear relationship, so if you think about linear relationship say that between two factors, it can be y and x. Your line can be this way, your line can be this way, your line can be this way, your line can be this way. But non-linear relationship, same concept if you apply in y and x, but if you go this way, then this is not a linear relationship. Or you go this way, that's not a linear relationship. Or you can go this way, or you can go this way. So in easy language, if you have more than one power, so if you have one power, like example here, only one power, so that most likely it will be linear relationship. But if you have square or more than power 1, then most likely it will be a non-linear relationship. So what we are going to study is linear relationship. So far so good. It means between two factors x and y, we have some relationship, and that is a line, and the power is only 1. It means both sides, y equal to, it can be x. Now x has only one power. Now multiplier can be anything, doesn't matter. You can add something here, doesn't matter. But as long as the power is 1, likelihood that you have linear relationship. So that's the first thing we need to find. Now, let me show you something interesting. In a school time, if I give you like this type of graph, I'm sure you must have studied a graph. So there is no question about here your origin. Okay. Now, if your origin here, and if somebody say that you have to point this value, like example 3, 2, and this is your x-axis and this is your y-axis. So normally what you do, this is 1, this is 2, this is 3. So it means your data may be somewhere here. And this is, let's say y1, and this is 2, this is 3. And whenever somebody give you coordinate, first coordinate is always x and second coordinate is always y. So you go to 3. So this is 1, this is 2, this is 3. And then you go for y, which is 1 and 2. It means this is your coordinate. And if you ask, hey, can you draw this thing? Maybe 2, comma 2. So first is X, second is the Y. So you put it here. Now, this is the way you can easily plot the data. I can give you minus also, like example, X minus 2, Y is 3. So minus 2 means I'm going to be this side of the X, right? Minus 2. And the Y is positive 3, which is this side. So I can plot the data, which I think we know very well. Now, if I ask you simple question that if X is less than 3, so this is one of the constraint I have. Please understand, one of the constraint I have. So if I want to do constraint, how can I do? So here I draw a line, right? And it's X less than 3. It means somewhere my result can be here, can be here, can be here. Do you guys agree or not? But I don't know. Is it here? Is it here? Or is it here? I don't know. Now, if I say I have another formula, another thing called Y has to be greater than 2. So now, if I have Y greater than 2, so if I draw a line, Y is here, and greater than 2 means it can be somewhere here. Make sense? Now, what happening is in a linear problem, there are a lot of constraints you have. So let's do this thing so you will easily understand. If I say, please understand, try to understand this thing. Let's say I have formula like Y equal to 3X plus 5. If I say X is 1, you can easily predict by putting value here. So 3 times 1 plus 5. So you can easily predict 8. But instead of just saying X is 1, if I say X is greater than 1, what would be the maximum value of Y? Can you guys help me? What would be the maximum value of Y? Can you tell me? Sorry?
Infinity.
Perfect. It means when I give X is greater than Y, it means I can put X infinity. So in that case, Y equal to 3 times infinity, right? Plus 5, it means Y will be. But if I add another constraint that Y should not be greater than 7. Now tell me, what would be the value of X? And I want to get Y maximum. I want to get Y maximum, but Y should not be greater than 7. Can I get it?
Roughly 0.6.
Think about it. So I want to
0.
I think you are understanding correctly. Listen carefully. X first condition is this thing. X has to be greater than 1. Right? So if I put close to 1, let's say if I put 1 here, as soon as I put 1, Y is what? 8. But I'm saying that Y has to be less than 7. Here I'm saying X is greater than 1. Here I'm saying Y is less than 7. Can I satisfy both constraints?
Like 0 minus, it's going to be in the minus.
No, think about it again. The first constraint, X is greater than 1. So here, if I put 2 here, if I put 2 here, 3 times 2 will be 6, 6 plus 5, Y will be 11. Means this constraint will not be satisfied. If I try to satisfy this constraint, then this constraint cannot be satisfied. Make sense or no? Please understand, I cannot put X less than 1 because this is the constraint. Make sense or no? So whenever you are doing this problem, linear problem, it's a very interesting problem. So listen carefully now. If you are doing old fashioned, like example, old fashioned, we say like X plus Y equal to 6. In that case, please understand, in that case, what would be the maximum value of x?
6.
What would be the maximum value of x?
6.
Very good. Yeah, make sure you participate. It will help you. 6. And what would be the maximum value of y?
6.
Very good. So if I draw a line, it means I can put lot of data and I can still get the 6. Example, I can have 6 0, I can have 0 6, I can have 3 3, I can have 2 4, I can have 4 2, I can have 5 1. Do you guys agree or not? I can have 1 5, I can have 3 3. There are a lot of solutions available. Do you guys agree? But the solution will never be this side. It is all somewhere here. Do you guys agree or not? If I put x 0, then y is 6. If I put y 0, then x is 6. If I put x 3 here, then y is 3. If I put x 2, then y is 4. Do you guys agree or not? If I put 4 here, then y is 2. Means all the solutions will be inside this triangle. Do you agree or yes or no?
Yes.
So in a linear programming world, this is called feasibility zone. Feasibility zone. Please remember this word, feasibility zone. Feasibility zone means I will have a lot of solutions available here. I will have a solution here, but I can give you guarantee I will not have solution here. 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 It will be only available here. But will I have only one solution or I can have many solutions? What do you think?
Many solutions.
Many solutions. Do you guys agree? You can see many solutions. So now the linear programming, please pay attention. It's very useful. Linear programming, when you perform, you are looking for many solutions. But from many solutions, you might be interested only two type of answer, either max or min. Max or min. Now, in this situation, if I say, please understand, I have one formula like this. And I say, if you have X, let's say assume X is table for us easy language. If X is a table and Y is a chair, just like learning purpose. Every time I make one X means one table if I make $10. And every time I make one chair, I make $5. $5. So how much maximum profit I can make? How can maximum profit I can make? Every X I make $10 profit and every Y I make $5 profit. So what is the maximum profit I can make? Think about it.
What is the equation? X plus y or?
Yeah, this is the equation. This is your equation. This is your equation. This is your solution. This is your solution. You have so much solutions. But I'm saying every X you make, every X you are making $10 profit. And every Y you make a $5 profit. So my question is, what is the maximum profit you can make?
$60.
Okay. Are you guys agree with Muthi? Yes or no?
Wouldn't it be 15?
Sorry?
Wouldn't it be 15 since if we solve for x, right, that would be 10. If we solve for y, that'd be 5. So
No,
would that be 10 plus 5 or?
No, it's not like that. Every X Every X, you make $10 profit. Every Y, you make $5. So if X is 2, you make $20 profit. If X is 3, you make $30 profit.
Then wouldn't your answer be infinite since if
no,
you know your X,
why?
is
You
there
just
like
saw. No, you just saw here,
constraint?
right? Yeah, you just saw here, right? You just saw, right? X plus Y equal to 6. And you yourself say that X maximum I can have is 6, right? You just mentioned here, right? And you also mentioned the Y maximum can be 6. So this won't be infinite, right?
Mm-hmm.
So now knowing that formula, X plus Y equal to 6, every X you make $10 and every Y you make $5. The question is how much the maximum profit I can make? Murthy says 60.
60 at a max, 30 at a min.
Very good. So do we agree that based on this solution, X I can go is the maximum 6. So if I go to max 6, then if I do 6 here, then it will be 60. In that case, will I make any table? Sorry, chair?
No.
No. Now, let's assume there is a requirement that you have to have minimum QY. Now, what would be my profit, maximum profit? Minimum I need to have Y, means I need 2 chair minimum.
$50.
So if you need minimum 2, so you're gonna put 2 here, right? But here is 6, so X will be 4. Yes or no? So 4 plus 2, which is 6. So 4 means every time you make X4, which is nothing but $40. And every time you make Y, you get a $5, but here Y is 2. So 2 times 5 will be 10. So your maximum profit will be 50. Make sense? Let's say if requirement is you have to have X at least, listen carefully, you have to have X at least 3 or more. 3 or more. What would be the maximum profit would you target? Don't worry about this one now. At least 3 or more. What would be the maximum profit would you target?
Again, 60.
Very good. So what we are just doing, it's a simple problem. Very, very simple problem. But through Excel, we are going to do very complex problem. And that is where linear problem solving comes in picture. Linear problem solving in our real life, 70 to 80% problem in the linear solving. So first problem, let's talk again. It's called product mix. So when we say X plus Y, and then we give this thing, let's example, I give 10. So this is called product mix problem. It is called product mix problem. It means X and Y together, maximum you can have is 10. But if I put these conditions like this, that X has to be greater than equals to 3. Y has to be greater than less than 2. And if I say every X I make $10 profit. Every Y I make $5 profit. Then things getting interesting, because here is not X direct value, but here you are saying X is greater than 3. Here you are saying Y is less than 2. So if I draw graph just like that, and if I say X is greater than 3, it means if I put here, and this is 3 here, X, this is the X axis, and you're saying greater than equal to 3 means you are saying your solution is somewhere here. X can be anywhere value here, right? That's what you are saying. But you are saying Y has to be less than 2. Y has to be less than 2. It means if I draw Y here, so this is a 2. You're saying Y can be anywhere here. So as soon as I see cross where X and Y is crossing, this is only Y, but here you can see I have crossing X and Y. It means my solution is somewhere here. My solution is here. So this become my feasibility zone. This become my feasibility zone. So it means solutions is somewhere here. Now I have to think about what are my objective. Objective is every time X, then I make $10. Every time Y, I make a $5. And these are profit. So if I'm thinking from profit perspective, I will always think about maximum profit. Do you guys agree or not? Because my objective is profit, then I'm thinking about max. So now I know there are a lot of solutions here. So what I'm going to do here, I need to get the maximum solution. So if X is greater than 3, so I say, oh, I'm making more profit in X. So what if I make it 0 here? Because this guy is saying Y has to be less than 2. So I'm going to put 0 here. As soon as I put 0 here, X equal to 10. If X equal to 10, then 10 times 10, maybe my objective will be now $100. Make sense or no? You say, but why you're putting 0? Because as long as I satisfy this condition, if I put Y 0, is 0 is less than 2? Yeah. So this condition is satisfied. And if X is greater than 3, if I put X is 10, then this condition is also satisfied. So if I put 10 and 0, this condition satisfy, this condition satisfy, and I get this equation. So the X value is 10. So every X I make $10. So if I do 10X, I will make $100. Do you guys agree or not? And this is very important. This simple example is very important. Any questions so far? So far, so good? Give me thumbs up if you're so far following me. Okay. Now, I want you to understand 3 terms. The first term is constraint. The first term is called constraint. Constraint. So this is one constraint. This is second constraint. The third is objective function. So objective function here is like this: 10x plus 5y. This is your objective functions. It means every x you multiply by 10 and you are going to get a profit out of it. So when it is objective function is profit, you're going to do max. So that's your goal. So your objective function is 10x plus 5y. Your goal is to make profit. So this is your objective functions. But in order for you to get the maximum profit, 2 things are changing. Either x is changing or y is changing. So you can only change these 2 parameters. So that is called change set. Change set. So let me repeat again. These are constraints. So you have to meet those constraints. So first is the constraints. So here these are constraints. The second is the objective functions, that every table you make $10. Every chair you make a $5. That's your objective functions. But in order for you to make maximum profit, you are allowed to change X and you are allowed to change Y. So change set is X and Y. Now we are doing very simple equations. So that's why we can manually or mental math we can do. But what if these constraints are more complex? What if we have bigger value, humanly impossible to calculate this answer? In that case, Excel gives you very interesting thing called solver. What they call? Solver. So the solver, Excel has a wonderful solver, and using the solver, you can solve much more complex linear problem by continuously changing value of X and Y, because this X and Y are here in a millions of permutations. So what solver will do, solver will keep trying thousands of times and then try to see the maximum objective functions. And when it comes, it will show you. So Excel doesn't know that putting value of 10, I'm going to get 100. Excel is going to keep trying. Excel will put 5, Excel will put white 1, they will try many permutations and then get you the best objective functions. And that is coming through the solver algorithm. And that algorithm we are using, Xsolver, is actually speaking a plugin available in Excel. And that plugin randomly use value of X and Y to satisfy this constraint and maximize the objective function. So many jobs you're applying, they may say explicitly, they will say Excel solver knowledge is essential. They will explicitly ask, you need Excel solver knowledge. It means linear problem solving knowledge. It means three things: how to satisfy the constraint, how to maximize, change the change set, and how to maximize your objective functions. These three things you need to understand. And in order for you to do all those things, that whole process is called LP. LP stands for linear problem solving. You do not need to know math. Listen carefully. You do not need to know math. You just need to know how to set up this linear problem in Excel. And if you know how to set up this in Excel, you can solve complex problem, very complex problem. Very means very complex problem where human, without proper tools, human takes months to solve that, which you can solve in a minutes. And that is why this is one of the most important skill for data analysis perspective, Excel perspective, you will learn. Any questions so far? So far, so good? Okay. So now let me first walk you through the slides, our Google class. I'll show you the slide first, and then we'll do the exercise. Okay. We will do a couple of exercises, so it will be easier when you do this. When you do this thing, it will be easier. Let me start the Google class. Oops, not here. Where the Google class went? Oops, not here, is it? Where did I put a Google class? Here you go. You may like this thing, okay? So stop me anytime if you are not very clear, because the most important thing is understand the concept, and then we'll slowly solve the problem, okay? So first I'll start this PDF file. All those PowerPoints are here and some labs raw materials are here, okay? First, understand the mechanism. These courses, which I am covering right now, it is coming from MBA. So if you are taking MBA course, these are the things are covered there. There is a whole subject in MBA which is called quantitative analysis. Quantitative analysis. Quantitative analysis is one of the things called numeric analysis. And part of that whole subject you learn quantitative analysis called linear problem solving. The second subject is called advanced linear problem solving. And the third is called supply chain linear problem solving. Fourth subject is called simulations of the linear problem solving. So if you do 4 subjects, then you do data analysis major in MBA. If you ask me, whole MBA, the biggest problem people have is they don't get it. Linear problem concept, they don't get it. So one of the most difficult problem people are having in this class is they don't know the mechanism. I can give you guarantee in 1 hour you will understand. You don't need to know MBA. You just need to listen to me. You have to practice what I say. There are 6 to 7 problems you will learn. Okay, and you are equivalent to MBA. You may do homework and you can build your muscles. And I'll give you project also for this. But you just need Excel. And please keep asking questions. Truth must be told. When I studied, I can tell you, I don't want to tell my professor name and all. but they taught such a difficult way. We were 22 students, and within a couple of weeks, we become 7 students. And this class, I used to do 20 hours investment in a week. 20 hours I was investing, and light bulb was not happening. Light bulb. After a lot more effort, light bulb happened on 5th week. And after that, everything is simple. I taught this class hundreds of times, and I have seen 0 student have problem. What does it mean? It is the art you understand this thing. If you understand the mechanism, then you solve the problem. It's a lot easy. Majority time people don't understand mechanism, and then they try to solve the problems. Without understanding mechanism, if you try to solve problem, most likely you will have a tough time. So what we're gonna do, we're gonna do this exercise multiple times today. So today my goal is to just teach you mechanism. Next week, we're gonna solve complex problem. You may love it. And our complex problem, which I put in agenda. This is what people will ask you when you go for interview. Complex problem, first problem, product mix. This is the easiest problem. So if you are working in a manufacturing company, should I manufacture table? Should I manufacture chair? Should I manufacture vaccine 1, vaccine 2? Should I manufacture laptop? Should I do iPhone? Should I do like appliances? What should I manufacture? So this one is a manufacturing problem. Should I do fertilizer A, B, or C, like that? So this is a product mix problem, easy problem. 30 to 40% problem you will see manufacturing. So if you are applying for a job in a data analysis world, and if they are using manufacturing company, then they will ask you, do you know LP? And product mix, they will ask you in interview. Next one, you may love it. Networking problem. So if you are working on logistics, Amazon, Walmart, don't think about the store job. These are real jobs. Example, if you have a warehouse and from your retail stores, and from there you are taking your truck and driving truck to your retail store, or maybe you want to go to your distribution center, and from there you want to go to different store. How would you make the decision? How would you take the item from one warehouse, because their company might have many warehouses? How you will take the item and deliver that item to particular store? What kind of road you will take? What kind of path would you take? What kind of truck would you take? What kind of driver would you take? What day you will take? Why would you drive? All those things is networking problem. We sometimes call logistic problem. I myself work in USPS. When we did a project, USPS project, Walmart, Amazon, any retailers you think about, they all need logistic analyst. Chicago is a hub of logistics. So anytime you have a delivery, point A to point B, logistics required. You can take to the next level. You can say, if my manufacturer is in China, what kind of path would I take? Would I take cargo? Would I take a plane? And from there, would I take train? Entire logistic model you need to do. If you are having a UPS, like if I have 5 packages to deliver, how my driver will deliver the packet? What is the cheapest way I can deliver the packet, or fastest way, or safest way? So cheapest, fastest, safest, those are constraints. How would you do that, right? So that we will talk about it. Football game. So if you are picking a team member, like example, you want to pick the strongest team, how would you pick the strongest team, right? If you are thinking about election perspective, or if you are thinking about whom should be promoted, or if you are thinking about store perspective, which store we will close, right? Which store we should close. Those are called selection problem. So that's called football game. All those things we are doing, these are highly required skill, but only being taught in a MBA level. I'm teaching the same thing. It may take me 2 weeks to cover that, and trust me, you will be able to do. The humble request is you do homework. If you do homework, muscles will build, because it takes light bulb. Remember, it takes time to do light bulb. Mechanism, I will teach you today, but light bulb only will happen when you do it. When you do a couple of times, light bulb will happen. My process is very simple. But what happens when you don't do the practice, you will know mechanism, but you will not know solution aspect. In a real life, they don't expect just mechanism, but they know how to solve the problem. Some of the things will not be clear in the sense of it will not be given in a simplest form. And I will walk you through all those things. And that's the reason I'm going to give you some case study also. Any questions so far? Any questions so far? So far, so good. Are you guys excited? First of all, tell me, right? This is one of the, in my management, this was the toughest class I had. And trust me, after learning, my rest of the class become the easiest class, because this class was the foundation class, and they we call quantitative analysis. In case if you search in Google, you will find lots of books. Books are very expensive, almost like $180 books you used to get that, and many materials you will get for quantitative analysis. So I'll give you materials and all. Don't worry about it. So let me get through the slide first. So there are a couple of slides I have. First, I'll go through this one. So here you go. I created my own material to make life easy. So first of all, why we are studying Solver? So Solver is a really good. It's simple tool, very simple. You don't need to be a mathematician, and you don't need to be a genius in a math. What you are trying to solve, you should know. So you need to identify, is it a product mix problem? Is it a networking problem? It is a logistic problem. Is it a supply chain problem? Is it a football team problem? So there are 9 models are there. So you have to find out what problem you are trying to solve. Trust me, you will have a 0 problem. But initially, when you are not knowing, everything will be unknown to you. But today we are only solving product mix problem, and we're going to do a couple of time practice. So that way you will be comfortable, and I'm going to give you some homework also. So first identify what problem model you're using. When you're doing that, you also need to certify this is the linear problem. If you do not have a linear problem, then none of this solution will work. Okay. So linear problem, we talk about y and x, where x is power 1. Make sure you understand that. If it is a power 2, then there is no way you can do that. How do I define model? Whenever I say model, don't be confused with that. It is nothing but math, which you see in math. Take the math and put that math in Excel. But you will say, but I don't know math. Don't worry, I'll show you. But sometimes you will have paragraph. You will have paragraph in English. So you have to take English and convert that in a math formula. And then from math formula, you need to put it in Excel. So it takes a little time to convert that. I'll prepare you. Tonight, we're going to take math straightforward and we'll convert Excel. So that is called mechanism. Then we'll try to read in English. From English, we'll convert into math, which is called model. Creating model takes time. However, if you pay a little bit of attention in English, you will understand that. After few exercise, you will be able to comfortably convert English to math formula, and that is a model. What kind of solution can I expect, right? We talk about what makes a model hard to solve, because sometimes people don't get this model. In this model, you will have a change set, something is changing. There will be a constraint, right? Something you have to correct, and there will be objective function. So from this English, you have to find out what is changing, constraint, what I need to satisfy, right? And what is my objective functions. So sometimes it is hard. Don't take me wrong. As I said before, 22 students out of that, 14 students disappear. I'm glad I did not give up. Why I didn't give up? Because for me, I want to graduate and I want a fastest way to graduate. I wish they explain mechanism first and model. It would have been a lot easier. But what happened? It depends on professor. They try to do all at once. So first of all, you don't know the mechanism, and if you have to try to do that, it is overkilling. And I have seen surveys say that this was harder because people, they don't know the Excel part and they try to solve. So that's why knowing Excel part problem is 70% solved, and then knowing English to model, which is kind of 30% part. We'll cover that. Can you show me step by step? And that is what I'm going to do that. Sounds good? So let's move forward. So Excel. Excel is the best way to solve this problem because Excel has an algorithm built in to solve the problem. Anything you do, raw material, machine time, anything you do, people, money, material, time, everything you can analyze. Then you can analyze and you can come up with the constraint. What constraints I need to work on? You will come up with the change set. What change I need to make? And you will come up with the object. It's a lot easier to do. And then Excel solver has automatic option called best, which is nothing but max, and worst, nothing but mean. You can define that type of objective functions. So let me show you some example. I'll come back, so don't worry about it. Now I'll go with this thing. Okay. So please pay attention. First of all, I have a model here. Please pay attention. X plus Y. We just discussed in a few minutes, so you will not have a problem. X plus Y less than equal to 5. So what does it mean? It means no matter what value of X and Y you do, it has to be less than 5. So whenever somebody gives that, you try to do a graph, right? And let's remove just less than, and you just put like this, X plus Y is 5. So in that case, you know the maximum value of X will be 5 and maximum value of Y will be Y. It means your solutions are here. So that is your here feasibility solution. Now here another thing, X is greater than 3. So they are saying X is greater than 3. So that's your constraint number 1. So if X is greater than 3, then you can put here, let's say X is 3. And if X is 3 here and they are saying X is greater than 3, it means you may need to say solution somewhere here. But then there is another constraint, Y is less than 4. So there is a constraint called Y is less than equal to 4. It means now you need to find out another constraint. So Y is here, Y is 4. So it has to be solution somewhere here. So now everything match here. So it means your solution is somewhere here. Now from this feasibility zone, you need to find the best solution. And that is what we're going to do. Now, the best solutions Excel is find from the concept called, random forest. It is concept called random forest algorithm. Now, random forest algorithm Excel is using. Now you will say, what is this random forest and how does it work? I have no idea. So let me ask you one thing, and this is very simple question. Please try to understand. If I take you in the forest and if I ask you one simple question, find the tallest tree. How would you find tallest tree? Anybody can speak. I take you to the forest and I drop you somewhere in the middle and I ask you to find the tallest tree. How would you find the tallest tree?
It's basing on my vision.
So you are standing here, right?
Yeah.
And Murthy, you will see lot of trees. So now you can say maybe this tree, maybe this tree, maybe this tree, maybe this tree, you will find, right?
Yeah.
So let's say you say, oh, this tree is tallest. So you go here. When you go here, your vision will change, right? Yes or no? You will see more other tree. Yes or no?
Yeah.
Now you will compare, yes or no? And then you will find this tree. When you come closer to this, you might find more trees. And you say, you keep comparing till you find the biggest or tallest tree. Yes or no?
Yes.
So that is the same concept we are using. So first you are saying this is called iteration 1, means you loop 1. Available trees, you loop 1 and you find, say, this is the tallest tree. But when you come here, you say, let me find other loop. Then you found, oh, there is another tool. That's iteration 2. And then you, oh, there is another tree, iteration 3. So if you try 100 iteration, what will happen? Would you find almost tallest tree? Yes or no? What do you think? Yes or no?
Still may not be.
May not be, but we're very close. Orebi, yeah, go ahead. What do you think, Oreb?
I think we have to do sampling, like random sampling.
Yeah, so we are trying to do random, right? So sometimes I have to go to left side, sometimes I did right side, sometimes maybe front, but concept will be same, right? Concept will be same because you found first tree and you're not going to say this is the tallest. You're going to compare with other trees and see, is there any other available? You will keep trying, keep trying, keep trying. You tried 100. So from 100, let's say you found tallest trees, let's say 60 feet. This is an example. If I, instead of 100, if I do 200 attempt, maybe I may find 62 feet tree. Yes or no? But between 100 to 200, the gap is not that big. Do you guys agree? Say yes or no. Or maybe your voice is coming very, very light. Oh my God, I cannot even hear you now. Other people, are you guys able to hear?
No, she just sound really, really quiet.
Yeah, you may want to speak close to the microphone maybe. Okay. So do you guys agree that if I continuously increase my attempt means iteration. If I continuously increase my attempt, I may find better and better tree. Yes or no? So can I make infinite attempt? Can I make infinite attempt? Yes or no?
No.
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 So question remain, if I do 5 attempt or 50 attempt or 500 attempt, the difference between 5 to 50 is very similar, maybe 1 feet or 2 feet only. But in 5 attempt, most of the time, I might be able to find the almost tallest tree, almost, not the base tree, not the tallest tree, but almost. But for 5 to 50 or 5 to 500, my accuracy increase. Do you guys agree? My accuracy increase. But sometimes I don't have time to do this thing. So time versus accuracy, you need to think about. Do you guys agree or not? Because if I can get in 5 attempt almost tallest tree, then why would I spend time and go to 500 attempt? Because it's going to consume time, it will cost me money. So sometime we may be lucky that in 5 we might be finding the tallest tree, then I don't have to go through 500 times. Excel solver does the same thing. They keep finding if I X value, Y value, and say what is the objective function. Am I getting the highest? Then again next X value, Y, and say am I getting the highest object? And they compare. If they compare, they keep looking, they keep looking, they keep looking, they keep changing X, Y, keep changing, keep changing. So they do iteration and they continuously check the objecting functions and see objecting functions is getting higher and higher and higher. After a while, they see the objecting function is not changing that much. Then they will give up and say, this is your almost highest value. There is no guarantee this is the best solution, but given iteration or given attempt, I found this is the best and that might be closest to the best. So Excel solver internally use random forest algorithm. Make sense? And random forest algorithm gives you very close to accurate result. Question, concerns, doubt. Are you guys understanding concept so far? Any questions so far? Why we are using random forest? Because in this feasibility zone, there are millions of solutions. How many? Millions of solutions exist in this feasibility zone. Millions. So you cannot do million attempts. So random forest concept, you keep changing X and Y and check objective functions. If it is higher, then you try to go closer to that. And if you don't find it, you go and find the which one is closest. And then you kind of, try a couple of attempts and you declare this is the best solution. But whenever you are trying to find, you try to meet all the constraint. Make sense? Your solution should meet all the constraint and get the best result. And solver will do that part for you. Questions?
Are we going to limit the number of iterations?
Yes, and that is what I'm explaining.
Uh,
The 5 to 50 is your choice. If you want more accuracy, maybe you can increase the iteration, but it will take a long time. If you don't want accuracy, then maybe 100 iteration is good enough. After that, there is no need to go, because the difference will be like this: 5.00006. So this is your called precision. How much precision you want? If you want 5.0 only, then you may be done in 10 iteration. But if you want 5.006, that type of precision, you need more iteration. So precisions require more iteration. Make sense? The more iteration, more time it will take. Our Excel solver is using our CPU power. If you remove the CPU, listen carefully. If you remove the CPU and if you do manually, it will take months. It will take months. But because you are using Excel solver, you will do in less than a minute. And that's the power of our CPU. When people do this type of calculations, to be honest with you, they use the supercomputers, because scientists and those people who are doing space shuttle and all, they are using this type of formula and they do all permutations in order to come up with the best result. Yes, Kenwak.
So the final result, will it be a single result or will it be in range, for instance, with the 3? Oh, okay.
You can get final result will be the best objective functions you're going to get. Best. You get a best after certain attempt, but you will get the one. And I'm always interested in max or mean. So that's the reason you will only get one answer. Make sense?
Okay, thank you. Yeah.
Okay. Now common sense question. Listen carefully. Common sense question. Okay, listen. Here I have X and Y. So change set is my X and Y. Sometimes we call decision variable and sometimes we also call change set. What we call change set means I can change X and Y to get the objective function. So sometimes we call decision variable and sometimes we call change set. Now I have a question. Anytime your condition that is called constraint. So this is one. Constraint means condition. And whatever you are trying to do or trying to focus, that's called objective functions. So there are always three things you have: change set or decision variable, constraint or objective functions. Now my question, listen carefully. Will you always find solution, or sometimes you may not find solution?
Your constraints can be so poorly placed that there's no values.
Perfect. Thank you, Mike. So what happened if sometimes you may have contradictory constraints? So if you say X has to be greater than 6, impossible, right? So sometimes you may have constraint which you cannot meet at all. You cannot meet at all, or they might be contradictory because two constraints are so conflicting that you cannot get a solution. And you may end up like that. So listen carefully. Linear problem doesn't mean guarantee solution. If there are conditions, if there is a problem is a linear model and constraints are in a reasonable range, listen carefully, reasonable range, then there is a solution. Example, I want to go for vacation. I want to go by plane, then cruise, and I want to stay in some resort. Okay, so plane, then train, and the resort. So now plane, I can use different type of plane tickets. I can take different type of train ticket and different type of resort tickets. So I have X, Y, and Z, 3 decision variable. which flight to take, which train to take, and which resort to take. But if somebody said that I want to take only non-stop flight, if you put constraint, and a train, I want to take this kind of train, and resort, I want to have a 5-star. So as soon as you add a constraint, and then you can say, I don't want to spend it. So first thing, anytime when you do linear problem solving, always remember you need to know 3 things. Always remember you need to know what problem you're trying to solve, which is the objective. Is it a mean or max? And we need to find a formula. Second thing, you need to know change set. What you can change, so then you can adjust it. And third thing, your constraint. So always remember 3 things you need to know: objective functions, what changes you're making, what you can up, down you can do, right? And third is the constraint. So for time being, I'm going to do this exercise, and I don't want you to do right now. Just relax and enjoy the ride. Okay, I'm going to do this exercise. Let me take the screenshot so we can, I can convert these objective functions step by step. I'm going to stop all those things so you will not be able to see this thing. Let me stop all. So all are sold. Okay, perfect. Please relax. Don't do anything. We'll do together after when I explain this, because I want you to pay full attention. It will be a lot easier once you understand. So I'm going to create a new Excel, and I'm adding this picture here so we can always refer this thing. Okay. Now, this is the already formula is given to us. So formula is given to us. This is our objective functions. They say X1 is the product 1 and X2 is a product 2. And they have given us 3 different constraints. You will say, what is this constraint? Whenever you see condition, it's constraint. They also have given this thing. So they have 4 constraints: 1, 2, 3, 4 constraints, and this 5th. Let me make it simple for you. I'll do the simple one first. That way it will be easier. This is a little harder. So let me do the simple for you, because that will give us a better understanding how the process works. Where did it go? Where is my here? Let me take an easy one. Easy one first, then we'll do hard one. Let me try this one first, because if I try easy one first, it will be easier than I try complex one. So I'll do this one. So you can see here the model. The model is given here that we have X plus Y less than 5. That's one constraint. Anytime you see this, it's one constraint. X is greater than 3, second constraint. Y is less than 4, third constraint. And profit is this. This is the objective functions. And you have X and Y. This is something called change set. So how do you do this thing? So first thing you have to do right here, relax. Don't do it right now. Just you're going to see here what I do. So you write here, what is this X and Y? So first I'll write here, this is the product 1, just an example, product 1 and product 2. So I'm giving a heading. It can be table, it can be chair, it can be a classes, what kind of classes you are doing, anything, just write that. Now X and Y, because I have 2, so I have product 1, product 2. Pretend this is X and pretend this is Y. Okay. Now I'm going to put here like starting 1 and 1, just an example. So basically one product 1, which is in our case X, 1X and 1Y. And I'm going to change this. So I'm going to highlight that and I'm going to make it like pinkish color, because if it is changing, we do like this type of color. So it's kind of changing. Changing means it's Excel solver will change this, right? So first you write product 1, product 2, anything you can write. You can write table, chair, you can write X and Y. For time being, if I write X and Y, it's not going to be a problem, right? Like that. So you write that. And you write 1, 1, you can write 0, 0, but write 1, 1. There is a reason I'm going to do. So this is my change set. So I'm going to write change set or decision variable. Give me thumbs up if you are clear so far. Why am I using X and Y? Why am I using 1, 1? This is just a starting point. Okay. So change set you can easily understand based on this parameter. So if it is G is involved, then you need a 3 parameter, 1, 2, and 3. Very simple, right? So here we have 2 parameters. I'm going to put it in center so it looks good. It's easier to follow. Okay. So first is change set. Now you're going to write constraint. So constraint, so you can see here you have first constraint. Let's pay attention. Everyone, make sure you pay attention. So if you see X plus Y less than 5, so you can see here X, so it's 1 here. It's not there because 1 time X is X and 1 here. So 1 time Y is Y. So there is a 1 is already there. So 1 time X plus 1 time Y. So what you have here? 1. And what you have here? 1. And when you multiply 1 time X plus 1 time Y, then you get less than equal to 5. So how do we do this here? So the way you do here, because it's X plus Y. So here is 1. So you can see here 1 because it means 1 time X plus 1. So this is 1 time Y. So this one I can put it here. Can do 1 time X, and if I put 1 here, it means I can use 1 time Y. But I have not done it. I'm trying to do it here. Why am I using 1, 1? Because the formula is X plus Y less than equal to 5. So if it is not written, then it's a 1, 1. But let's say the formula is like this, X plus 5Y. Then I would have written 1, 5. Let's say formula is like this, 3X less than equal to 5. In that case, I'll use 3 here and there is no Y, so I'll put 0 here. Let's say formula is like this, 5Y less than equal to 6. Then there is no X, so I'll use 0 here and put 5 here. Make sense? Any question? You might notice that this is my X column and this is my Y column. I have not yet created a formula yet. I'm just seeing what value is here. Based on that, I'm adding here. So if I do this way, so 1 is here and 5 here. How am I going to do formula? I'm going to explain in 2 minutes, but I always look for the prefix or multiplier with the X and Y. So if only multiplier available X and there is no multiplier, then I put it 0. If only Y available, then X is 0. Questions? So far, so good? Okay. Now, for this one, what should I put? Tell me, what should I put for this one? For this constraint?
Start with 4.
What should I do?
I said 4.
Sorry?
Because X is should be greater than 3.
No. It's not like that.
Huh.
We have to create model. We are creating model right now. So for X, don't worry about this whole formula. Now. What do you have here?
-1, 0.
So this value, sorry, it's my mistake. It's not a minus, it's 1 here. So basically I should put 1 here
1, 0.
and 0. Make sense, Murphy?
Yeah.
We are not putting value. We are putting here what is you have instead of in front of X. And for what about this one? What should I put?
1.
1 or 0, 1?
0, 4.
0, 1. Make sense or no? Please
Oh,
understand.
yeah,
This
yeah.
column is X. This column is
0,
Y.
1. Yeah.
Make
Yeah.
sense or no?
Yeah.
Yeah.
Yes.
0, 1.
So right now I'll put here 1, 0, and I'll put here 0, 1. Please stop me anytime if you are not clear. So just to give idea, I'm going to write here so you can understand why I'm writing. So here is a single quotation just to explain the constraint I'm doing. Single quotation, Y less than 4, single quotation, X greater than 3, and single quotation, X plus Y less than equal to 5. Do you guys agree? I think someone needs to mute.
Okay, man. I'm glad to hear that.
Mute all. Sorry.
What's
If
up,
you're not speaking, I'll keep you in mute, please. This is like, as I said before, this is not a simple topic. Okay. This is very, very important. If you pay attention, life will change. If you don't pay attention, this is like, it's not, you will not find like a book or material. I can tell you, this is the best video you will ever find. So make sure you pay attention. Okay. So first of all, we are looking our multiplier, and based on that, we are putting 1 for this is 1 and 0, and here 0 and 1. We put that. And now we have profit. This is my objective functions. So here I'm going to put here objective. And what is the value here? What should I put here based on this one? What should I put here?
5
5
and 3.
So you understood very well. So far, everyone understand why I put this value? If you have any question, please ask. I'm hoping everyone is clear. Now I need to create this thing. I need to create this thing. So how will I create? So 1x. What is x here? This is your x. And this is your y. So if I do this thing, multiply this, then 1 times x plus, if I take this, then 1 times y. Instead of y, I put it 1. So I can say 1 times 1. And instead of x, I put 1. So 1 times 1 plus. So I can do that. Yes or no? Please understand, we are pretending x is 1 and we are pretending y is 1. Because it's a change set. What a change set means, Excel solver will change this enough to get the maximum objective functions. Make sense? But we are starting with 1. So if I want to get this for this side of the wing, then I need to multiply this versus this versus this. If I want to get this one, how should I do? Very simple. This is 5. This is your x plus 3 this. Makes sense or no? So how do I do that? So they have a very good function called sum product. So check it out. I'm going to write this thing. We're going to write here. Please understand. We're going to write here. Ready? I'll say equals sum product. And then you highlight this. So this is your change set. This change set, you are automatically multiplied by this thing, and sum product. Product means multiplication and sum means addition. It will automatically take this item, multiply by this item, plus this item, multiply by this. That's why it's called sum product. So you highlight this and press F4. Make sure lock it. Why? Because this sum product I can apply to everywhere. Make sense or no? Because I want to lock this so I can apply everywhere. So I'm going to press function F4. So I'm going to say function F4. So it will lock it. So that's my first range, comma, my this range. So if I have 2 items, and if I had 2 items, automatically it will multiply that. And if I press enter, it's going to get me 2. So just check it out. So if I put 3 here, see what happened. So you got 4. So why you got 4? 3 times 1 will be 3. And 1 times 1 will be 1. And 3 plus 1 will be 4. So if I put 2 here, I should get 5 here, right? So very good. If I put here 3, so what will I get? It's 9. So check it out. 3 times 1 will be 3. And 2 times 3 will be 6. And 3 plus 6 will be 9. So it's working. So let me reset back to 1, 1. Any questions so far? Any question?
Yeah.
Mm-hmm.
So
Mm-hmm.
I understand this constraint and objective.
Mm-hmm.
And while writing change set,
Mm-hmm.
you showed me x plus y is equal to something.
Mm-hmm.
So
that is this one. Mm-hmm.
Oh yeah.
Mm-hmm.
No, what my question is, while writing constraint, we write here X product and Y product. And whereas in change set, we write exactly X value and Y value. That's correct?
Yeah, so please understand. Do you know X plus Y less than equal to 5?
Yeah.
What is the multiplier with X?
1.
And what is the multiplier with Y?
1.
1. So you will put 1 here, right?
Yeah. Yeah.
But do you know what is the value of X? You don't know. And what is the value of Y? You don't know. It's a million. Remember the forest? There are millions. So this value will change million times. Okay. But anytime it changes, the constraint 5 has to be correct, right? And that's what we are trying to do. So give me a few minutes. As I said before, mechanism takes time. Remember, people, as I said before, it's not, I'm trying to explain in the easiest form. It will take time to understand mechanism. Once you understand mechanism, things will become easier. Okay. So right now I'm resetting back to 1. First of all, what is some product means? Make sure you understand some product. This is change set. So change set take this thing and this thing. So because here X plus Y, so you can see this is X time 1 plus Y time 1. You got a 2. I put 1 and 1 just an example only. Okay. So now I can drag this thing like this and I get the whole formula. So if I double click here, you can see now some product means take this. So what is that means? 5. This 1 is not 1. It's actually X. So 5X plus 3. And this is not 1. This is Y. So 3Y. So this is what I made. So some product will take this item, multiply by this, plus take this item, multiply by this, and will make 5X plus 3Y. So far, so good. Please understand, change set remain fixed for all of them because that's nothing but X and Y. So that's why we highlight and we lock it. We lock by pressing F4. And then this one is this range. Because I lock it, I can easily drag it and it creates everything. This is called your left side, this side. I created this side of the wing, left side. Then I'm going to do this side. So what is this one here? Less than equal to. So I'm going to single quotation, less than equal to. And here I'm going to write 5. And here it's a single quotation greater than, and I write here 3. Single quotation less than, and I write 4. Now do the math. Sorry, properly understand what we are doing. We are saying this is my model. Actually, this is my model. What did I write here? This is X plus Y. So that will create X plus Y, which is nothing but this one. So if I change the value of X and if I change the value of Y, this one will change automatically. But whatever value it change, it has to be less than 5. So that's my constraint. Here you say X greater than 3. So I don't know what will be the value of X. So if this change, then this value will change and the multiply this value will change. So these, no matter what happened, but this has to be greater than 3. So now this side is my left hand side, right? Left hand, right? LHT. And this is my right hand side, right? Why? Because this is the formula. This formula you are getting here. And this one you're getting here. And in between that, you have a constraint. In order to get this formula, you need a value of X, which will change. And you have to multiply this. Plus Y value will multiply. And whatever addition happen, that you wrote here. So this value will change as this value is changing. So example, if I put here 5, just an example, you can see that value will change. And 5 is less than 5. So computer will allow. But if I made it 10, computer will not allow. So that is what we are gonna do it. Make sense or no? So at this moment, all those things is a sum product, and the sum product is nothing but taking this value plus taking this value, and you put it here. This formula less than equal to they have given, and the right hand side they have given, we put it right hand side. Now our goal is very simple. What would be the value of X and Y? Listen carefully. What would be value of X and Y that these value remain maximum? That's what we want to know. What would be the value of X and Y where I get the maximum objective function? So this is my target objective function. So most of the books, they highlight this and then they will put as a blue color. So I'm going to put a blue color so at least you can see that this is something our objective function. We want to find out the maximum value of this, but we don't know. So we're going to change this thing. But when we change this thing, we want to make sure these constraints are matched properly. Means this condition has to be true. So this will change. This has to be true in order to get this maximum value. Questions? Questions? Are we able to see this thing or no? So here, how many constraints we have? 1, 2, 3. How many constraints we have? 1, 2, and 3. Sometimes these are explicit constraints they have given us. Sometimes we may want to add another constraint which are hidden constraint. Example, can I have X minus? Can I have X minus? Say yes or no.
Yes.
In this, it is possible, but real life, can you have table minus? Can you have -5 table?
In products, no, but if we can count losses, lost time, lost hours, lost product.
Correct, but table, can I have a 5 minus table?
Most likely no.
No, right? Not impossible, right? So in that case, I may want to add additional constraint that X has to be greater than 0. Can I have 2.2?
Yes.
This one try to do that, but in a real life, can you have 2.2 table?
Oh, no.
No. So in that case, we need to put X has to be integer. Make sense or no? We are trying to convert a real life here. That's why the creating model takes time. So these are the things as we go further, you will learn, right? Because in a math, X plus Y, you can do like this. X is 1.9, Y is 0.1 equals to 2. You can do that in a real math. But in real life, 1.9 table has no value. It's just a 1. And 0.1 chair is not even chair, right? So in real life, it is considered as a 1 table. So we need to think from real life perspective, right? Right now, we are just understanding mechanism. So I just want to make sure you understand certain constraints are explicit and certain constraints are hidden, right? Good news, everything is given to us. Profit functions is given to us. So this is my change set. So I just use 5 here and 3 here. And then after using 5 and 3, I use this 5 times this thing. And this is what I got through sum product. So sum product, when you do sum product, you do change set. And change set, the first change set, you take this, and then you took this, you got this. But this is not the real value. This is just an example based on 1, 1. The real value comes when I do the solver. Make sense? Any other questions? So what we are making decision here? What decision we are making right now? What decisions we are making right now?
Finding X and Y values.
Very good. That change set is your decision. And what is our objective?
Profit.
Profit. Max or minimum?
Max.
Very good. If you understood this, then you understand most of the thing. There are 3 things. Our goal is to find out what would be the value of X and Y. So I get the maximum profit. But at the same time, my constraint has to be true. You cannot get the, see, please understand, if I ignore this thing, then I can put X infinite and I can get infinite profit. Yes or no? But because I have a constraint, I don't know the X and Y. That is the reason I need a solver. Do you guys agree? Because if I ignore this constraint, then I can put infinite and I'm done. But because I have a constraint, I don't know what would be the value of X. Humanly impossible. I will not be able to figure it out quickly. So I need a solver to help me out. Okay. So now let me use the solver. So step number 1, please follow me. Okay. Right now you don't do it, but see here. If you are not paying attention, every exercise will be difficult. If you pay attention, exercise will be easy. I give you guarantee. So before you start, put your cursor on objective function. So remember, this is your objective functions. This is your change set, right? This is your change set, and this is your constraint. If you understand this, in 2 minutes, you will have an answer. In just 2 minutes, okay? Because remember I was talking about MBA class, they could not understand this thing. And I'm going to repeat 2, 3, 4, 5 times. All students did not understand any of this. And then they have to solve the solution. Impossible. So we are trying to understand mechanism right now. Okay. So first thing, put your cursor here. The second thing, click on data tab, which is the last week we did. And we already have installed, a solver. So remember, we installed the plugin, right? We installed a plugin called solver. So under data, put the cursor here all the time, and there is a solver. There is a solver. So I'm going to click here. I'm going to click on solver. It's going to get a dialog box. So first thing, please pay attention. First thing is your objective function. Select max or min. Our case it's max by default, so we are good. Change set. So click your cursor here. And then just select this one. So we are saying that solver, go and crazy change that as many value you want. Go and change it as many as you want. So this is change set. So solver knows this is randomly, it will change. It will keep changing till it find the maximum value. So it will do that. Now constraint. So you can say add, and you select this one. Select this one. See the sign here, less than equal to. We have less than equal to. Then click here and select this one. So try to map it. Left side goes here. This symbol goes here, and this one goes here. And now do OK. So that one constraint we added. Add again. Click here. Now you have greater than sign. Oh, there is no greater than, so I'll say greater than equal to. That's fine. And this one. Add. Then you click here. Less than. There is no less than sign, so less than equal to is fine. And then this one. Okay, so you can see now we have 3 things done. Objective functions, it's max, change set, which is this one, and I have 3 constraints. Now I'm going to take algorithm, which we are using simplex algorithm, simplex LP. That's what we are using. Simplex LP, which is nothing but random forest. So we're going to click on simplex LP. Now you have options available. How many iterations you do? Remember, we talk about random forest, how many trees you want to see. First, you will see this many trees and say, I like this tree. This is tallest. Then you do another thing, then another thing, then another thing, then another thing. So how many iterations you want to do? So you can click on option. So here it gives you precisions. So if you want this much precision, you can define. If you want to show iteration result, you can specify that. It means it will show keep changing X and Y, keep changing X and Y, keep changing X and Y, keep changing. You can see the result like that. So you can see the result. So you can say so result like that. you can say maximum time. How long should it run? You can specify. You can also specify iteration. Let's say I want to run only 10 iterations, or you can say 100, or you can say I will only spend 3 seconds. Get me result in 3 seconds. Or you can say run 1 million times. You can do that, right? Now I'm going to do OK. And are you guys ready? Give me thumbs up. No thumbs up? Ready, set, go. In second, you can see that now server pause, current solution display worksheet. So continue, and OK. You got the answer. So you got the answer. So it's a 5. You can see all constraints are met. All constraints are met, and you got the correct answer. Now, how did it get that? How did this get that? So it created a whole exercise where you can see. So when I ran the solver created. So let me run again. So you can see here, save scenario. So you can see here, solver pause, current solution value displayed on a workspace. So it shows 3, 0. So first value 3, 0. We got 15. I said, this is not right. Let's continue. So now it says 5, 0. And when I continue, it keep trying, but there is no better value he find. Solver found. So solver give up and said, this is the best answer I can get. Make sense? Now let's assume I change this value 50. Now I ask solver, give me the value better, because this is called changing the constraint. So I said 25. Go to solver. Solver says solve. Solver say, hey, first value 3, 15. Next value 50, 250. Solver found the solution. Make sense? Now, let me do again one more time. I don't want you to do right now. Just see here. I'm going to delete here. First of all, try to understand our original design. Original design was, yeah. So this is what we have, right? Anytime when you have problem, first thing what you look for, how many variables here? So how many variables you have? 2. So that's your change set, right? So change set, first thing you write here, X and Y, or product 1, product 2, table, chair, like that. If you want to do along with me, why don't you type it? Let's do along with me. Let's do together. So let me delete this thing here, and I'll put start with here. So it will be easier. So in a B, I write X, and C, I write Y. You also write, it will be easier, and change set. And write 1 and 1, and make it in the center, make it center, and do color, X and Y color, something pinky type of color. Why don't you type this and let me know if you're ready. Thumbs up. Good. I need everyone thumbs up, okay? Because this is only you can get this when you do it. So that's why make sure you do it. It's not hard. I can give you guarantee within 5-10 minutes you will feel comfortable, because once you start doing it, everything will make sense. Now we are going to add a constraint. So I'm writing a constraint, and I'm just single, right? X plus Y, single quotation, X plus Y less than equal to 5, right? So because it's X and Y, so X is 1, 1, and then here I'll say 1, 1, right? Just 1, 1. Why 1, 1? Because here you have 1 and here you have 1, and this X is nothing. So because you have product 1 and Y product 1, so we put 1. Do single quotation. What was the other thing? X greater than 3 and Y greater than less than 4. So X greater than 3. So it is only X available, single quotation, X, only X available. So 1 and Y is 0. In the single quotation, Y is less than 4. y is less than 4. So x is not available. So 0 and y is 1. Now write objective function. In objective functions, we've been given, I think it's 5 and 3. So let's do 5 and 3. So 5 and 3. 5 and 3. Give me thumbs up if you are able to do this. Awesome. Eva, everyone is doing good? Good. Now put your cursor here. Put your cursor here and say equals some product. Some product. Equals some product. Some product. Normally what I write like I write sum and P and then tab. So it will write that. Now you highlight this change set like this and press function F4 or just F4 until you get a dollar sign like that. Make sure there is a dollar sign because change set will not change. That's the only one. So it won't change. So you can highlight and function F4. Then do comma and then highlight this. Close parenthesis and press enter. Press enter. If you got a 2, and once you have that thing, right? Remember, some product, you first select this thing and you do function F4 to lock this thing. Make sure you lock it, and that's why you get a dollar sign, function F4. Then comma, and then you highlight this range. So there are two ranges. This one is highlighting this range, and this one is highlighting this range. And press enter. Once you do that, you just drag and drop and see if your values and my values are matching. Give me thumbs up if it is matching. If not, ask questions. Matching? Please understand, you have to follow this one lock. If your values are not matching, means you're doing wrong. I will do again one more time, but it has to be properly done. Well, see 1 0 1 0 0 1 values are properly done here. Say equal some product. Then you highlight this and do function F4. Function F4, comma, and then you highlight this. Close parenthesis. Press enter. Then you click here and just drag this guy here. As long as your values are here, it will multiply that, and you can see right away 1 plus 1 will be 2, and 5 times 1 will be 5, plus 3 times will be 5 plus 3, 8. So you can see 8. So if you click here, double click here, you will know that it is taking this range. Double click, always double click, so you will know you're taking this range and multiplying this, the sum product. Sum and product means multiplications. Got it? Now, because you have these equations, these conditions, so this condition we need to put. So single quotation, just do single quotation and put conditions. So I'm going to do, sorry, my mistake. Yeah, you did. Yeah, single quotation and conditions. So it condition will be visible. Single quotation, conditions, single quotations and conditions. Make sure you dot those conditions, because we have greater than, less than, sorry, less than, equal to, greater than, less than. Make sure those conditions are properly done. Now right side. So this is now a left hand side and this is the right hand side. So left hand side is done. Right hand side 5, 3 and 4. So now write 5, 3 and 4. Make sure the lines are properly adjustment, right? And this is your objective functions. So you highlight and put blue color in objective function. Normally, all books are normally like that. So we are following that because this is the way it does. So this is your change set. This is your constraint. And this is your objective functions. If you have that, put your cursor in a objective functions. Go to data tab. Go to data tab and go to solver. I am assuming that you have already added data analysis toolpick, right? Data analysis toolpick. In case if you have not added, you want to go to file, options. Remember we did in a first class, so that everything is there. So right now I am here. I'm going to go data. The solver come from the plugin which we add in Excel, which is data analysis toolpick. Click on solver. Now let me remove that so everything will be matching to you. I'm going to do all, reset all. So let me do here. Now, first thing you do is your cursor is already here. So you should see this thing selected. So if it is not selected, make sure your cursor is here. So that is selected. Always remember this blue thing, because you are color coding, it's a lot easier to see here. Make sure you select max. Now put your cursor here. And then once you select cursor here, you select the change set like that. You draw and select the change set. So you just draw, that is selected, this change set. Right? Now click on add. So when you click on add, you do one by one. So take first item, which is this one, right? Take the first item, make sure the comparison sign is properly selected, and then click your cursor here. Click your cursor and click here. So if you carefully notice, this item is this one, this item is this one, and this item is this one. And that's your first constraint. Then you do add. Then do the same, select this. You have to flip the condition because it's a different condition. Make sure you don't make mistake in a condition, because otherwise answer will be different. Add and do the same. Make sure all constraints are correctly done. Okay. And in a drop down box, select simplex LP, because that's your random forest. We don't have to provide options right now. Option is for more customizations. And now just do solve and give me thumbs up if you are getting the correct answer. Let me know if you are getting that. Okay. Anyone else got it? Koi, congratulations. Okay, good. 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 So let's understand one more time. See, I have change set. I have constraint. I have objective functions. Make sense or no? Anyone has any question before we do the second exercise? That will give you clear picture. Mike, Matthew, any questions?
I just must have entered something wrong. I got solver could not find a feasible solution.
Yeah, so that's why please pick up this way. Otherwise I will go forward. So first of all, do you have this number? Let me do 1, 1. First, make sure your number and my numbers are matching. Please help me.
So I have 211 on the left side and 534 on the right side.
Okay. Do you have this signs properly?
Less than or equal to is the first one. And then we need, oh, there you go. Yep.
Because if you flip the condition, it is a different constraint. Okay. We need to be very careful because otherwise the constraint will be quite different. Sometimes it will be opposite constraint. After you make the changes, go here, put your cursor here, right? And go to solver. And if you made a wrong conditions, you may want to select it and delete that constraint. Delete that constraint. You can click and delete the constraint and recreate the constraint. Make sure the constraints are correct. Sometimes if you made a mistake, if you don't know which constraint is correct, just delete all and step by step add one by one. Make sure you select simplex LP and see if you can run it and get me the answer. Everyone got 25 or anyone got higher than 25? Everyone got 25, right? Good. And you can see how beautiful this dialog box are. Objective function, you cannot make mistake. Change set, you cannot make mistake. And constraint, which you add here. So they have nicely done. And this is your algorithm. And just need to click solve. Make sure you follow the conditions you have given. So first condition was less than equal to, we have that. The second condition greater than equal to, we have that. And third. And if you do solve, it will solve for you. Good. Mike still having issue?
I'm getting there.
Anyone else have any issue?
I don't have any issues, but I just want to point out that
Sure.
you also clicked on options earlier, so maybe that's what Mike is missing.
No, you don't have to do options. You don't have to do option because option is for more precisions. You don't have to do options. It's just about precisions. You don't have to do. Because this is a simple problem, within a few seconds it will calculate. Option is for more precision. I'll show you when it is needed. Right now we have pretty simple model, so it's easier. If you have this condition wrong, let me just show you. So if I click here, just an example, and I say change. Let's say I accidentally made a wrong selection. Instead of greater than, let's say I made this thing. I did okay, right? And if I try to solve, I might get a wrong, different answer. Why? Because I made a wrong conditions. So sometimes you get an answer, but it's incorrect because it's condition wrong. So we need to be very careful when we select the condition because the conditions has a magic, and that's why it's very important we select. And when we select, this side is always left side first, and this side is always right side. Okay, and if you do it right, most of us will have similar answer because the way random forest works, it will be almost similar thing. So you will see that. So if these numbers are not coming, then when we did a sum product, right, you itself you have a problem in that, then it will be visible. So like example, if you did a sum product and you didn't do F2, F4, right? Many times people make that mistake. So that's why I keep saying that when you do change set, make sure you do F2, F4. So you lock that. After you lock that, this condition, and then you drag this thing down. So that should not be a problem. Then make sure you have proper this condition according to this model. And then this value should not be different because sometimes if you made this value different, you might have different result. After that, put your cursor here in and then step by step add objective functions, change set, and your constraint. And make sure you select simplex LP. Sometimes people don't select simplex LP, you may get a different result, and then you click solver. Good. Mike said thumbs up. Let's do one more. Okay. So this will be fun. So let's create a tab. This time we're going to do a little bit complex one. Okay. This time we're going to do a little bit complex one. So it will be fun. So this time we are going to do, let's do a complex one. This is all explanations I was giving. Yeah, so this time we are going to do this. So let me take a screenshot and put it so I don't have to switch around. We're going to do this one, okay? So create a new tab. I'm going to put it here. Okay. Let me know if your new tab ready. It won't take more than 5 minutes because now you know everything. How many chain set we have? How many decision variables you have?
Decision variables 3.
Very nice. So you know one thing very well. Decision variable. Very good. 3. Okay.
Yeah.
Now how many constraints you have?
4.
So 1, 2, 3, 4, 5, 6, 7. So 7 constraints.
Okay.
Total 7 constraints, right? And where is the objective function?
8x1, 5x2, plus 10x3.
So this is your objective functions. Make sense? So now we know everything. So let's create a model. So we'll create a model. So first I'll write here x1, x2, x3. And I just put 1, 1, 1. I always start with starting point 1 and I format a little bit. So it will look good. And I color code this. And I always do like pinkish color like that. And here I write change set. Can I write 0, 0? You can. Nothing wrong in that, but 1, 1 gives me some comparison. If I put 0, everything will be 0 starting point. So your number and my number will not be verifiable. So that's why I'm using 1. So we can verify the value. Give me thumbs up if you're done with that. Change set, color, formatting. Good, 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 good. Now let's write objective, sorry, my mistake, constraint. You don't have to exactly use the same row. You can use different. So for first one, you can see here 2, then this one is 1, and this one is 3. So that one I'll write single quotation, 2x1, right, plus x2 plus 3x3 less than equals to, sorry, we have English here, right? They have called plastic. So I'll say plastic constraint. Now production time. Production time, the constraints is given. So here, this one, clear 3, 4, 5. Wow, that's easy. Now total unit. Everything is 1, 1, 1. That's easy. Now space. You can see x1 and x2 is there. So x1 is 1 and x2 is negative, so minus 1. x3 is not there, so 0. Let me know if you're having any questions so far. I read this thing and I translate this thing. Please understand very clearly, this is minus 1 because here it's minus 1 and there is nothing here, so 0. So that's why it's 0. Should not be a problem now because this is mapping our constraint model. Question, concerns, doubt? Okay. Now we'll write a objective function. So here we have 8, we have 5, and we have 10. It's clear, very, very clear. Should not be a problem. This one is mapping here 8, 5, 10. X1, X2 is already there. So it's mapping, mapping, mapping. Now, if you are done with that, then we'll say left hand side. So what should be my formula now? Same formula, sum product, sum product. This time you're going to highlight all 3 and F4, function F4. Make sure you highlight and function F4. Then comma, and then highlight this thing. and close parenthesis. This step is very important. You highlight this thing and press F4. Then comma and highlight this and put it. Because you have 3 variable, you have 3 value here. And press enter. Now drag this guy down so you can calculate everything. And in 23 I get, give me thumbs up if you are getting 23 when I have 1. So at least I know that you and me are on same page. Good. Now slowly and steadily add these conditions. Add these conditions. Okay. So first one is single quotation less than equal to, single quotation less than equal to, single quotation less than equal to, single quotation less than equal to. So you have all less than equal to, which is kind of very nice actually. And 1000, make sure you write number correctly. 1000, 2400, 700, 350. So this is right hand side. So normally I kind of, this is left hand side, this is right hand side, this is your conditions. This is most important. Make sure your number and my numbers are matching, and double check one more time that numbers are not wrong, because otherwise your answer will be wrong. Good. Now we are trying to do solve, and within a second we have answer. So put your cursor in objective functions. Put your cursor. The reason I put 1 1 here, because if I put 0 0 here, you will not see any value here. So that you will not know. We cannot compare your value with my value, because that's the reason I put 1. So at least we can have some number, so we can compare our value. Hey, you had 23, I have 23. But if I put 0, everything will be 0, and then it will be difficult. Are we doing right or wrong? So that's why I always do 1 1 1. So at least we can see something. I know this will change. Who will change this thing? Our solver will change that. So don't worry about that part. You just put your cursor now. Now go to solver, data, solver. First thing first, always remember objective function has to be selected. Max has to be selected. If it is looking max, otherwise minimum. So for this is done. So step 1 is done. Step 2, click cursor here. Look for change set. Highlight this change. Sorry, highlight this part and select this change set. Oops, my mistake. Solver. So click here. You highlight change set. Then add. Now here I want to give you a secret, because they all have same, please understand, because they all have same sign, you can select entire portion at once, entire portion like this, because they all have same sign. You don't have to do one at a time. Please understand, they all have same sign, so you can select all 4 condition like this at once, all 4 condition at once, because they have only all same sign. Then same sign, and then click your cursor here and select this. It's kind of easy because they all have same sign. So you select this side, which is here, and this sign, which is here, and they all have same sign. Now you do OK. So you do OK. Don't forget to select simplex LP. So only one condition, simplex LP. I did not add this condition yet because I want to see that is there any problem. So I'm going to delay this condition. So now I'm going to do solve, and you can see now beautifully it got the answer. Let me know if you are getting the same answer or if you have any questions. Right? someone say, I want to add this condition. How would I add? Very simple. If I want to add this condition greater than 0, it's very simple, right? What do you need to do? Add and highlight this, all three. Highlight all three. So this is x1, x2, x3. And you're saying greater than 0. So just put here greater than 0 and put it 0 and say OK. And you run, you will not see the different result. Result will be same. Doesn't matter, because if this goes negative, then this condition would be helpful, but it is always remain positive. The condition is not a problem. The reason it is not going negative, because advanced Excel, the Excel which you are using is advanced, has this check mark. And if you carefully see this, it does say that non-negative. So I don't have to add these conditions. But if you are using old version, you have to add these conditions. New version, they clearly say that this cannot be negative. So that's why it is. Any questions, concerns, doubt from process perspective?
The commas in the x1, comma, x2, comma, x3, comma is greater than 0. That's just saying, is each value less than 0? That's what it's saying?
Yes, okay. Yes. So that's why we select entire chain set. So when I did that, see here, what I did, I selected entire chain set, because what you are saying, all three are greater than 0. So I selected entire chain set here and then say greater than 0. It means each item x1, x2, x3, all has to be greater than 0. That's what it is. So rather than saying one by one, you can select one by one also, but because it's condition, see, x1 is greater than 0, x2 is greater than 0, x3 is greater than 0, like that, right? That's what they're saying. So you highlight this thing, which is I did, and condition is still same, which is I had, and 0 is 0. So rather than doing 3, I can highlight it, because just like I did here, because the condition is same, I can highlight this thing in one shot, and I can add only one condition and avoid 4 conditions. You can do that.
Perfect.
Okay.
Perfect. Thank you.
So I'm hoping you all got the idea. Now, I just want to make sure, homework perspective, I don't want to take too much. I want to make sure you are soaking this process part, right? So homework perspective, you can see here in the slide, I have some example. Please understand. The slide has the homework here. So please play around. There is an example 23. You can see this is another example. This has a little bit of English. See if you can convert English to model, if you can, and try this thing. If you can, try this. Otherwise, I'll show you next week. But when you try this one, you will have some more confidence. Then try this one, you will have some confidence. It is not complex. They have given you X. This is your X. This is your Y. This is your G. And this is your A, whatever it is. And rather than less than equal to, they have given English here. So you can use like that. Read this English. So they have given right side here. So this is your right side they have given you. And then this is your objective functions, which is nothing but like this way, 450 here, multiply by this. So this is your objective function. Then this one is this one is this. So when you play around, you will get the answer. And same thing here. So they have given, when they say at least, means like this, x1 greater than equal to 500 calorie. So they say find a minimum cost diet that contains minimum cost diet